So these are the objectives that we talked about yesterday before we were rudely interrupted to go to the assembly, okay? Solving quadratics by factoring, solving quadratics by the square root property, solving quadratics by completing the square, solving quadratics using the quadratic formula, using the discriminant to determine the number and type of solutions, and determining the most efficient way to use when solving a quadratic, okay? Just as a reminder, these are the notes that we took yesterday. We have the zero product property. You remember talking about that? Zero product property. When you have two numbers multiplied together and it has to equal 0, that means one of them has to be 0. Okay? Zero product principle, excuse me, not property. Then we reviewed a little bit on factoring trinomials. Gave you a trinomial, going to get two terms because we can do the shortcut because a is 1. We factor by AC method. But doing the shortcut gives us x minus 2 times x minus 5. If we didn't remember the shortcut, we need to say AC is 10, B is negative 7. What multiplies to be 10 and adds to be negative 7? We split that middle term into two parts and then factor by grouping. Okay? Pulling out an x and having an x minus 2 left, pulling out a negative 5 and having an x minus 2 left, factoring out the x minus 2 from each term, and what's left is x minus 5. So those are the two factors. We talked about the difference between factors and solutions. Factors is what we get when we factor something, and solutions is when we take those factors and set each of them equal to 0 to solve them. Okay, does that all make sense? Okay, so lots of different kinds of factoring. Factoring trinomials is one. We went over that. Factoring by grouping is one. We also went over that when there's 4 terms. Just look at the first two, look at the last two. Factor out what's common. There's also the difference of squares. Okay. Difference of squares is when you have two terms. It's a binomial. And you might have x squared minus 25. It's called the difference of squares because each one of these terms is a squared term. X squared is obviously squared. 25 is squared because it's 5 times 5. When we factor the difference of squares, we get x plus 5 and x minus 5. Anybody remember how we get those two terms? Anybody remember how we get this binomial and this binomial from that? Square roots, right? Square root of each one. That one in the front, that one in the back. Okay, x plus 5, x minus 5. So if we had 4y squared minus 49, what would our two binomials be? Two y plus 7. 2y minus 7. Any questions about that? What about the sum of squares? So if we had x squared plus 9, that's prime. Because we can't factor that. We can factor the difference of squares because of the fact that if I went ahead and multiplied that out just to check and see what happens, I'd get x squared and then I'd get minus 5x and plus 5x and then minus 25. So that middle term goes to 0. There's nothing that I can multiply times itself that would give me this x squared plus 9 again. Okay, so we can't factor that, the sum of squares. There's the difference of, CE. Difference of cubes. Remember we talked about this being a pattern? If we have a cubed minus b cubed, we end up with a binomial and a trinomial. Do you remember talking about this? So for the binomial, I take the cube root of the first term. For the second term in the binomial, I get the cube root of the second term. The first term in the trinomial is this term squared. The second term in the trinomial is this term times this term. And the third term in the trinomial is this term squared. And all that's left to put is the signs. The binomial is the same as the problem. The next one is opposite of that. The last one is always plus. And the cool part about that is we also have the sum of cubes. And when we have the sum of cubes, if it's a cubed plus b cubed, everything is the same except for the signs. The pattern of the numbers is the same. Even the pattern of the signs is the same. Whatever the binomial is, whatever the problem is, that's what the binomial is. The next one is opposite of that. The last one's always plus. Okay? So, difference in sum of squares, difference in sum of cubes. We talked about trinomials. We talked about factoring by grouping. You okay with that? I don't know what I did with my objectives. Did they fall? The next objective was factoring by the square root property. Okay? So if we're solving equations by square root of property. So if we have something like 3x squared minus 15 equals 0, what kind of steps do you think we would take to solve this problem? Add 15 to both sides. 3x squared equals 15. Now what? Divide by 3? X squared equals 5. And then what? Square root both sides. Who put the square root sign in the problem? We did. What else do we have to put in when we solve this? Plus or minus. Okay? This is not a situation where we can just assume the positive. There are situations where we could just assume the positive. This is not one of them. Okay? But there's also problems that we can solve like this using the square root property. Because we could multiply this all out and then subtract 6 from both sides and then factor what was left. But what happens if we would just take the square root right now? Couldn't we do that? That leaves us x minus 2 equals what? Plus or minus the square root of 6. And how do I solve for x? Add 2. Okay. Any questions? So for objective-wise, we've talked about solving quadratics by factoring. We've talked about solving quadratics by the square root property. What's next is solving quadratics by completing the square. Okay. Now we worked on that quite a bit in Algebra 2, completing the square, not because it was hard, just because there's lots of steps. Okay, so let me just remind you, not by just doing an equation, but by just doing a small expression. Okay, if I have x squared plus 8x, in order to complete the square, that means I need a perfect square trinomial right here. That means I need one more term. To complete the square, do you remember the steps? Okay, I will tell you. Take that middle term and divide it by 2, and then square it. What is 8 divided by 2? 4 squared? 16. What if it was x squared minus 10x? What goes in the blank now? Because divided by 2 is 5. 5 squared is plus 25. Is there ever time we're going to subtract something for that third term? No. Okay, no, there's not. There's not ever a time that we'll subtract something right there. Do we need to do ones that are fractions? Do you remember about that? X squared plus 3/5 x. How do you divide a fraction by 2? Can't we just multiply it by 1/2? Isn't that the same thing? So that gives me 3 over 10. What's 3 over 10 squared? Well, what's 3 squared? What's 10 squared? Yeah. Remember, when we're squaring fractions, we're just squaring the numerator and squaring the denominator. Okay with that so far? So now let's actually do a problem, solve a problem by completing a square. Okay? X squared minus 6x plus 4 equals 0. Now, the 4 is not helping us out anyway because I can't factor this. If I do AC method, there's nothing I can multiply to get 4 that I can add to get negative 6, is there? Okay? So I need to get rid of this 4. It's in my way. Jerk 4. X squared minus 6x equals negative 4. But I left a blank. I left a blank space. Remember doing this? Yeah? Okay. I left a blank space because what am I going to fill into that blank space? The square, right? I'm going to complete the square. What is negative 6 divided by 2? Squared. So if I plus 9 here, I also add to plus 9 there, don't I? Okay? Now, I go from my trinomial to my binomial. What is my binomial? This is a perfect squared trinomial, which means I can go to a binomial that's squared. X minus 3, right? Where does this term come from? There's two different places it could come from. Either half of that or the square root of that, right? And I just have to take the sign of that middle term that's there. Okay? Equals what? What's negative 4 plus 9? 5. Well, this is something we did just a minute ago with these notes right here, isn't it? Now that I have something that's squared, I can just take the square root of it to solve it. Here and here. So the left-hand side, I just get x minus 3. And the right-hand side, I have plus or minus the square root of 5. If I add 3 to both sides, I get x equals 3 plus or minus the square root of 5. Fundamental theorem of algebra says however many, or whatever my biggest exponent is, that's how many solutions I should have for the most part. Okay? So how many solutions should I have when I'm solving a quadratic? 2, right? How many solutions did I just get? I got 2. What's one of them? 3 plus the square root of 5 and 3 minus the square root of 5. Those are my 2 solutions. Everybody okay with that? Okay. Do I need to do another completing the square? You guys got that okay? Actually, I want to do another completing the square because I need to do one where the leading coefficient is not 1. This leading coefficient is 1, and that was pretty simple. Okay? Nine x squared minus 6x minus 4 equals 0. Whoa. So what do we do first? Can I complete the square if my leading coefficient's not 1? So I have to make it be 1. I have to divide everything by 9. Okay? So if I divide each term by 9, I get x squared minus 2/3 x plus 4/9 equals 0. Yes, thank you. Minus. Good catch. Now what? Same as before, there's just a bunch of fractions, right? Get rid of this one. Add 4/9 to both sides. God bless you. X squared minus 2/3 x, leave yourself a space, equals 4/9. 4/9 divided by 2, which would be a half, which would be 2/9, right? 4 over 18, which would simplify to 2/9. Oh my gosh. Ignore that part. Thank you. 2/3 times 1/2 is 1/3. Is that better? And then squared is what? 1/9. Thank you. Plus 1/9 plus 1/9. I think I just got excited that I was going to simplify the 4 and the 2 and forgot to look at the right term. Don't do that. Take the trinomial and make it into a binomial. What's the binomial? X minus 1/3. It's either half of this one or the square root of that one, remember? Equals 5/9. Square root. X minus 1/3 equals plus or minus the square root of 5/9. Now here's what I don't know. I have a suspicion, but I don't know for sure. Okay, I have a suspicion that your computer is not going to like this. Because if you have the square root of 5 over 9, that's the same as the square root of 5 over the square root of 9. And we know that one. So I think that your computer is going to want that. Plus or minus. Okay? So x minus 1/3 is going to equal plus or minus the square root of 5 over 3. Okay? Because then when I add 1/3 to both sides, x is going to equal 1/3 plus or minus the square root of 5 over 3. I do know that it doesn't want 1 plus or minus the square root of 5 over 3, even though those are equivalent statements. I know it doesn't want that because we were working with that last period. Okay? How are you feeling about completing the square? Remember it? More or less? Mostly less? Okay, that's fair. So factoring we've talked about, square root property we've talked about, completing the square we've talked about. Quadratic formula. Okay, we're going to talk about quadratic formula and the discriminant at the same time, just as a reminder. Okay, do you remember what the quadratic formula is? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you remember what the discriminant is? Yep, it's right there. That's the discriminant. It doesn't include the square root. It's just the thing that's inside the square root. So if I think about that real quick, if I have a positive discriminant, if my discriminant is positive, how many solutions am I going to have? Well, if this is a positive number, how many answers am I going to get when I take a square root? Negative b plus that number over 2a, negative b minus that number over 2a. I should get 2 solutions, right? What if that discriminant number is 0? Negative b plus 0? Is that going to be any different than negative b minus 0? So it's basically just going to be negative b over 2a. How many solutions is that? Just 1. And the other choice is if it's negative. If that's negative, that's an imaginary number, right? So I'm still going to get 2 solutions, but I'm going to get 2 imaginary. So can we go correct what we wrote earlier? If I have a positive number, how many solutions should I get? 2. What kind? 2 real. 2 real solutions. What does it mean by solutions? What's another way to think about that? If you plug it in and get 0, absolutely. Absolutely. Okay? Solutions are how many times it crosses the x-axis. If I have a parabola that crosses that many times, there's 2 solutions. The solutions are those 2 places where it crosses the x-axis. Those are 2 real solutions. One solution is going to look like this, where the vertex is right on the axis. Okay? no solution is going to look like this. It doesn't cross the axis at all. Maybe it's up there, maybe it's down here. It just doesn't cross the x-axis at all. Okay? So let's talk about this problem real quick. 8x squared plus 2x minus 1 equals 0. If I ask you to solve this using the quadratic formula, what do you got to do first? Identify A, B, and C, right? If I identify A, B, and C, then I just have to plug everything into the quadratic formula. But can you answer this question for me first? How many solutions is this going to have? What is b squared minus 4ac in this particular problem? Well, b is 2, so b squared would be 4 minus 4 times 8 times negative 1. So 4 minus a negative 32. What's that going to be? 36, right? Well, 36 is a positive number, so I should get 2 real solutions if I do all my work correctly. Yes? Okay. So now let's go ahead and solve this with the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, the cool part is I've already done this, so I know that that's 36, right? Do we know the square root of 36? 6. So negative 2 plus or minus 6 over 16. Can I stop there? I mean, I guess I could, but I'll get it wrong. Or not all the way right, because I can simplify that, can't I? What's negative 2 plus 6? 4. What's 4 divided by 16? 1/4, right? What's negative 2 minus 6? Negative 8 divided by 16? Negative 1/2. So those are my 2 solutions. Am I sure about that? I could check, couldn't I? 1/4 squared is 1/16. 1/16 times 8 excuse me, is 1/2. 1/2 plus 1/2 is 1. 1 minus 1 is 0. Okay, so I know the 1/4 is right. Negative 1/2 squared is 1/4 times 8 is 2. 2 times negative, that's 2 minus 1 is 1 minus 1 is 0. Yeah, so I know for sure that those 2 are correct. What's another way I could check and make sure that those are correct? I could graph them in the calculator, right? Graph this equation in the calculator and see if it crosses at 1/4 and negative 1/2. Okay? Any questions about that? There will be times when you do quadratic formula and you don't get a nice pretty number like 36 under here. What if it was 37? Couldn't I stop it right here? I would stop right there, right? If it was negative 2 plus or minus the square root of 37 over 16. Yeah? Keep in mind that when you put it in the calculator, in the computer, it's going to want negative 2 plus or minus, negative 2 over 16 plus or minus the square root of 37 over 16. It wants it into 2 parts. Okay? I know this is 36. And you know that you could simplify 2 over 16 if you needed to, right? Okay, but if that's an issue right here where we have something we don't know the square root of, it's going to want it in 2 separate fractions with the plus or minus in between. Okay? So far, factoring, square root property, completing the square quadratic formula, and we just talked about using discriminant. Okay? When or how do we decide what's the most efficient method to use when solving quadratics? It depends, right? It just depends on what's happening. If it gives you a trinomial that you can look at immediately and say, oh yeah, I can factor that, then factor it. Which one will always work every single time? quadratic formula. But is it always the most efficient? No. If you have something that's being squared equal to something else, shouldn't you solve it with the square root property? If you have just a squared term and a constant, shouldn't you solve that with the square root property? Just move that one term over, divide whatever you need to do, and square root both sides. That kind of thing. So that's how you decide that. It's not an easy thing to talk about. I would have to show you 18 different examples, but I think that we've done that pretty well in Algebra 2 and even in some of these examples. So if we look back at them real quick, this one, hopefully you realize we really need to solve that with the square root property. There's only a squared term and a constant. Get the squared term by itself, square root. This one is clearly something being squared equals something else square rooted. Okay? This is something you could do the quadratic formula on. You'll get the same answer, but sometimes completing the squares is simpler. Okay? If I was doing this problem right here, I probably would not complete the square to solve it. I would probably use a quadratic formula because the leading coefficient is not 1. If the leading coefficient's 1, I can probably complete the square pretty easily, like we did on the problem before that one, like this one. We completed that square pretty easily. There's not a whole lot of steps there. Here, there's a whole lot of fractions because of the fact that I had to divide everything by 9. Okay, so we did this with completing the square because I needed to make sure you remembered that. But if I just gave you this problem and said solve it, I probably wouldn't do completing the square. That would probably not be my first choice. I probably would use the quadratic formula. Or I would graph it and see if it crossed at nice places. This one would not. Okay, but that's what you have to do when you're trying to decide how to solve it. The most efficient method is just kind of look at the problem, see what's going on in the problem. Okay? So do you feel like we've succeeded with these objectives today? Yes? Okay. If you have any questions, you know I'll help you. Just have to come and ask. Okay?